In this video, we are going to learn and understand about the axiomatic approach of how to calculate the probability. Okay, see, when we talk about the axiomatic approach, first is you need to understand how probability comes into play. Understood? See, whenever we talk about probability of something, generally we could talk about probability of an event. Okay, so event can be whatever event, like it can be very simple, like a very simple event such as tossing of a coin, or a very complicated and a compound event such as predicting the weather on that particular day. Okay, so all these cases we have to calculate the probability of an event. So when we write probability of an event, we write it as P probability of an event E. Okay, see, probability of an event talks about how many number of times we are going to get that event. Okay, for example, if you take the tossing of a coin, simple example. Okay, tossing of a coin, say we are going to toss twice. If you toss it twice, then we have head head, head tail, tail head, tail tail. Correct? Say my event is calculating how many times we are getting two tails. Okay, say probability of getting two tails. So my event is what? Event is getting two tails, correct? So we can say that event is getting two tails. Getting two tails. This is the event. Now look at the number of times we have. See, number of times the two tails are getting is just one. Correct? So it's 1 out of how many are there? 4. So it's 1 out of 4. So probability of that event E happening is going to be 1 by 4. Correct? So can we generalize this? That means if we are writing the probability of any random event, so we can say that probability of an event E is number of favorable cases, or you can say number of times that particular event is occurring. That's a favorable case, divided by total number of cases, isn't it? So this is the empirical formula or the axiomatic approach to calculate the probability. Fine. Axiom meaning what? You look at it and you observe and get the formula, correct? That's basically an axiom. So in this case, we look at the way how probability works. From that, we derive the formula. That's why this is what we call as the axiomatic approach. Now, mathematically, if we need to write it, then we have, see, number of favorable cases. That means number of times the event is occurring, isn't it? So we can write P of E is equal to N of E, number of times the event is occurring, divided by total number of cases, correct? See, total case, don't you think this is nothing but the sample space? This is the sample space, isn't it? Sample space is what? S. So we can write N of E divided by N of S. This becomes the mathematical formula, or you can say the empirical formula of probability. That too, we are doing the axiomatic approach. This is going to be the formula. Understood, right? So probability or the chance of that event occurring is number of times the event will occur by the total number of events that are there in that particular set. That's why it's N of E by N of S. Fair enough? Now, what are the things you need to know in probability? Very important. Okay. See, the first one is whenever we talk about probability of an event, say P of E, right? So this P of E has a range of values. That is, P of E is always greater than 0 and less than 1. Or you can say greater than or equal to 0 and less than or equal to 1. So in this, if you see, there are two specific cases. One is if P of E is equal to 0, then we call this as an impossible event. I hope you guys remember from the previous videos, whatever we have discussed, impossible event. That means it can never happen. And when P of E is equal to 1, this is what we call as a sure event. It will happen. So these are definite cases, correct? That's why we don't say it's a chance, because probability is all about chance, isn't it? So whenever we have P of E is equal to 0 and P of E is equal to 1, we are looking at two definite cases. That's why there is no probability. It's mostly as a definite case. Okay, but anywhere in between, we have a chance, right? Suppose if my probability is say 0.7. So 0.7 is most likely it is going to happen, or you would say more likely it is going to happen. Okay, or let's say you have a probability of 0.5. 0.5 is what? Half, 50%. So we call that as equally likely. That means 50% chance. Or say you have a probability of 0.05. Least likely it is going to happen because it's 5% chance. So we have least likely to less likely, equally likely, more likely, most likely. So we have range of values because they're all probability, it's just a chance. It might happen, it might not happen, but chances of happening is more compared to this one. That's all. Understood, right? Okay. Now, since we have this one, let's look into other observations and certain things what you need to know for probability of an event. Say you have an event, okay, and that event completes the entire sample space itself. Fine. So in that particular scenario, what we have is n of E is equal to n of S. Correct? See, when n of E is equal to n of S, probability of such an event is n of S divided by n of S, which is basically 1. So we can say probability of the sample space, because E is nothing but the entire sample space, correct? So P of S is equal to 1. Now this is a very important relation, because using this one, say you have multiple events occurring in that particular sample space. Okay, again I'll tell you, there are multiple events which is occurring in that particular sample space. Then if you take the sum of everything, that is going to give us 1. Okay, an example is, say you're going to roll a die, a 6-sided die. Now probability of getting each number is 1 by 6, 1 by 6, because see, if you take my set A, or let's call the set as S. Say the sample space S is nothing but 1, 2, 3, 4, 5, 6. This is what you are going to have, correct? Now say event P of E1 is selecting 1. Okay. So P of E1 is going to become 1 out of 6. Because favorable case is only 1. This is the only favorable case. 1 out of 6 numbers. Likewise, suppose if you take P of E2. Say E2 is what? Selecting the number 2 out of those 6 numbers, which is going to be nothing but again 1 by 6. Isn't it? Because there's only one number, which is 2. Now, if you look at E1, E2, E3 till E6, all of their probabilities is 1 by 6, 1 by 6, 1 by 6. So, if you take P of E1 plus P of E2 plus P of E3 till P of E6, it's going to be 1 by 6, 1 by 6, 1 by 6, 1 by 6, all the way till 1. Isn't it? Now, if you generalize this one, then we are going to get P of E1 plus P of E2 plus P of E3 till P of En is equal to 1. Is equal to 1. So this is one of the results of whatever the empirical formula we have derived. P of E1, P of E2, P of E3, add everything, here you will get it as 1. Understood, right? Okay, now with this relation, what we can do is, we can figure out what is the complement of an event. First thing, what do you mean by complement? If you remember, complement is if a set is occurring, then complement is where the set should not occur, isn't it? Like for example, say, okay, say you have a roll, you're rolling a die. See, when you roll a die, you have 6 numbers, correct? Say the sample space is going to be 1, 2, 3, 4, all the way till 6. Now, my event P of E, probability of an event, for that, say my event is going to be set of even numbers. Very simple example. Set of even numbers. So, E complement is going to be what? Set of odd numbers, correct? Because set of even number and set of odd number, they should not be, they cannot be together. Complement is what? Something which is there in the universal set, but it should not be there in that event. See, when you take P of E is nothing but 1 divided by 2, because you are going to have 3 by 6. So 3 even numbers out of 6 numbers. So 3 out of 6, which is nothing but half. Likewise, if I take P of E complement, this is also going to be 3 out of 6, which is nothing but half. So we can say that P of E plus P of E complement is equal to 1, correct? Or what is P of E complement? P of E complement is equal to 1 minus P of E. So we can figure out the probability of the complement of an event if you know the probability of the event. Fair enough? So this is a very important relation. See, whatever we have done so far in this video, this is the basis for the upcoming problems, and I would say the entire probability what you are going to learn. All right. So remember, the empirical formula is 1. Second one, that n of e by n of s, that's the empirical formula. Then suppose if the probability of an event is 1, then we call it as a sure event. Or you can say the event is going to encompass the whole sample space, right? Next, if you have multiple events like E1, E2, E3, then the probability of all of them, if you take the sum of it, it's going to give us 1. Finally, the last concept what you've learned, the fourth one, is the complement of an event, which is this one. P of E complement is 1 minus P of E. This is nothing but the basics of the probability. In the next video, we are going to understand about one more very important relation, that is, what do we do when we have probability of A union B, A intersection B. Okay, all these things we'll discuss in the next video.